Um, the topic I'm presenting this morning might be a bit more special for most of you. It's an airport related topic, and it basically deals with this question. So, how can the capacity of an airport be expressed? And can it be with an integer, for instance, or is it more complex to express capacity of an airport? Well, in order to answer this question, we first have to understand or to agree on what capacity actually is, right? So if we look at the so-called practical capacity of an airport, it is defined as the number of landings and number of takeoffs an airport can handle within a certain unit time, for instance, an hour or 15 minutes, without or while adhering certain level of service requirements. For instance, the average delay of aircraft is less than a certain value. And in order to express capacity, you cannot do that with a single integer because you always deal with takeoffs and landings. And for that reason, you often use a so-called capacity envelope, which you see on the screen here. That's this blue function. It basically shows the frontier of what is possible and what is not possible. So all combinations of arrivals and departures which are within the envelope are capable, or the airport is capable of providing, whereas everything outside of this envelope is not possible. Well, of course, this envelope is subject to a large number of factors which affect its shape. On the slide, I provided you with, of course, a fictitious example of how weather and more precisely, for instance, visibility could affect this envelope. So the blue curve is the capacity envelope of the airport while the weather is good, whereas the red curve refers to the capacity envelope when the visibility is not good. And you see the red curve is smaller than the blue one, so therefore capacity is lower in this case. Besides weather, there are other factors which are quite well researched in the literature, being the number and orientation of runways, for example, being the layout of runways. For instance, you have airports where you have parallel runway systems, others have a cross runway system layout. Then you have a thing called the runway configuration. This is nothing but how the runways are actually used. So which runways are used for takeoffs, which ones are used for landings, and so on. Composition of demand is something of great importance. So is the airport frequented by a homogeneous fleet mix or not? That affects capacity a lot. Separation standards, for instance, is also something which is of importance. And of course, weather conditions. And all of these factors are quite well researched, and there is literature available. However, what literature is not available at the moment, at least, is how the existence of a so-called rapid exit taxiway, or short RET, affects these envelopes. And this is what we have been doing. And with we, I mean me and my colleague, Benoit, who sits here in front. So before I can really move forward on how these capacity envelopes are affected by RETs, I might have to provide you with a little bit of theory, short excursus into airport design on what rapid exit taxiways are. Here you see an aerial overview of Frankfurt Airport, of one of its parallel runways, and marked in blue and in red, you see in total 6 rapid exit taxiways. These are taxiways which are located at an acute angle to the runway, and they basically allow landing aircraft, and that's important, it's only for landing aircraft, to turn off and leave the runway at higher speeds. This way, the so-called runway occupancy time, that's what was just mentioned before, can be reduced. And if you can reduce the runway occupancy time, then in theory, you can operate more movements per hour, and therefore you should have a higher capacity. So that's the capacity gains which RETs could provide. And our goal was to measure it on the basis of OSN data. So how did we do that? Well, first of all, we had to find airports where we could measure such an effect in the first place. And we came up with this list of 7 European airports where a rapid exit taxiway has been added recently to the runway systems. And these 7 airports, we had to apply certain selection criteria in order to pick one. So first, of course, the data in terms of OSN has to be good for these airports. Then we wanted to look at airports where before the rapid exit taxiway addition and after, demand is more or less the same, so we can leave out any COVID-related influences. And the taxiway really has to be used in order to increase capacity and not just to smoothen out operation. This is especially the case in Zurich, where they built rapid exit taxiways to smoothen operation, not to really increase capacity. So in the end, we had to pick Lisbon as the only airport which really fulfilled all these selection criteria. So here you have a runway overlay, an overview of Lisbon Airport. You see in red the 2 rapid exit taxiways which are available on runway 20, and one of it, taxiway Hotel 1, is the one which has been added or built in December 2021. So we look from now on to Lisbon Airport, and we explicitly look at Lisbon Airport when it is operated in a way that aircraft land on runway 20 and take off on runway 20, because otherwise we cannot measure the effect of the red. So knowing that, we went to Open Sky and we downloaded 2 monthly data sets covering the month of October 19 and the month of December 2022. These months have more or less an equal number of movements, so they're in this way balanced. One is referring to the so-called pre-red conditions before the red was added, and one is referring to the post-red conditions after the red has been added. Then we looked at trajectories, or the part of trajectories below 4,000 feet, and we classified trajectories as the ones where the average climb rate is higher than 500 feet a minute, and which spend more than 20 seconds in this box here as takeoffs on runway 20. And in terms of landings, we considered trajectories which have an average climb rate of less than 100 feet per minute and which are aligned with the extended runway center line for more than 30 minutes as landings. So once we had these data sets, we did a little visual inspection and we stumbled upon this fact here. So when you look at the trajectories of arriving aircraft, we found out that especially in the pre-red data set, which is the one from the year 2019, the trajectories ended quite a certain distance from the threshold and not at the threshold, whereas for departing aircraft, we had the same effect, but after the runway. And this is a problem if you want to determine the capacity envelope, because you have to know the time of takeoff and the time of landing. And in order to make up for this deficiency, we trained an XG boost model which allowed us to calculate or to predict the time it took aircraft to fly these distances. This way we could then update our latest time and to find out the time of takeoff and the time of arrival. And here on the slide, you see the prediction errors, which again have the same issue as with Ben. I think it's a Mac related issue. Sorry for that. I hope we can provide you with the real data afterwards. So knowing the actual time of arrival and the actual time of departure, we could then start to determine these capacity envelopes. And this is done in a 3-stepped process. First, we had to split the observation period, pre and post-red, into 15-minute intervals and count numbers of departures and numbers of arrivals within each of these intervals. This is an easy task if you have a computer at your disposal. Then second, we had to calculate the so-called tau quantiles of departures for all observed arrival counts. So we had to find out what's the tau quantile if for all the observations where we have, for instance, 0 arrivals within 15 minutes, how many departures did we have in these, and so on. So we had to do that for all the arrival counts which we observed for Lisbon Airport. And then finally, we could fit a concave and non-increasing piecewise linear function to these quantile values. And this is basically then the capacity envelope. So that can be done with this optimization problem. And we ended up with these results. So first, I would like to show you 2 density plots. On the left, you see the situation before the red was added, and on the right, you see the situation after the red was added. The y-axis, they refer to number of takeoffs per 15 minutes. The x-axis to number of arrivals per 15 minutes. And basically, the density refers to how often did we see these combinations of numbers of arrivals and numbers of takeoffs in 15 minutes. Dark red means often, light red means less often. And what is obvious from at the first sight is we have a certain shift in density from 2019 to 2022. We expect, however, that this is not an effect which was triggered by the red. This is more how the airport of Lisbon is actually frequented by traffic. So that's demand structure, basically. What can be attributed most probably to the red, however, is what is circled in blue. So if we go to 7 arrivals per 15 minutes, we see that in the post-red case, we have slightly higher densities than in the pre-red case. That's a first indication that because reds provide capacity increase when only for landing aircraft, so we expect capacity increases to be seen in the areas where the airport is operated or frequented by a high number of landings. So having said that, these are the envelopes which resulted from our studies. Post-red, meaning after the red has been installed, is the red curve, whereas pre-red is the blue curve. First observation, the post-red envelope completely covers or envelopes the pre-red. So this is a first indication that post-red, the airport had more capacity than before. And then if we look at the left part of the graph, meaning where numbers of arrivals is equal or less than 5 arrivals per 50 minutes, we can see that the envelopes are more or less the same. Whereas when we look at the right part, it is you see that there are more pronounced differences. Again, reds have impacts on capacity when airport is frequented by a high number of landings. Therefore, that's what is to be expected from our point of view. If we look at the whole situation in more detail, and we pick, for instance, the spot where we have 5 landings and 5 departures per 50 minutes, which is 20 landings per hour and 20 landings, 20 departures per hour and 20 landings per hour, equaling 40 movements per hour. There we have an average runway occupancy time of 90 seconds per movement. And then if you move to the right and look at the situation where the airport is frequented by a high number of landings, we see that pre-red, we have 28 landings and 8 takeoffs per hour, meaning 36 movements, and an average runway occupancy time of 100 seconds. Whereas after the installation of the red, the total number of movements per hour could be increased by 4 movements, and the average runway occupancy time could be decreased by 10 seconds. So again, this is an indication for the circumstance that rapid exit taxiways increase capacity of an airport. So this brings me already to the end. In order to conclude, we can say, well, with open sky network data, you can measure the capacity envelope of an airport, given certain caveats, especially relating to coverage issues. So because there is sometimes limited coverage near the ground and on the ground, yeah, that's an issue which has not been solved nowadays. Then the capacity benefits of a RET become visible when the airport is frequented by a high numbers of arrivals. Therefore, that's what you see in the envelope when you compare pre and post rapid exit taxiways. And then, just as a final remark, I mean, since this is the Open Sky Symposium, and this is a wish for the future, at least from my perspective as a more airport interested user. So if ground coverage was better, not only on single airports where we know there is good ground coverage, but like in general, then I would say that a whole new field or whole new fields of research would open up, and I think an even broader audience would be able to benefit from Open Sky Network. But of course, I am aware of the fact that achieving this good ground coverage is an inherently hard task to achieve. So this brings me to the end, and I'm happy to answer questions.
Thank you for the nice talk. Any questions, I assume?
Yeah, I'm so thank you. Interesting. I have a question. Do you have any opportunity to, let's say, check with airport authorities about was this built-in effect when they decided to implement the RETs? Did you check with them that about your findings, if they fit their planned benefits?
Yeah.
And another thing?
Yes, sure.
It's more, you have a flight list as detected from Open Sky. Did you check if that correspond to the actual movements that were at the airport?
Yeah, okay. So regarding your first question, we had discussions with the airport of Zurich. That's why we know that the airport of Zurich doesn't use their RETs to increase capacity, but rather to smoothen operation. We have, however, not had discussions with the airport of Lisbon in this case here. And regarding your second question, yes, we used a certain Eurocontrol data set, which is, however, not something which we can show here. But this showed this was used by us as basically the ground truth. Yeah.
Okay, next question, please.
Can you switch on the microphone? Well, I don't think so. Ah, it was sorry.
Thank you. Okay. You hear me better now?
Perfect.
I have a fundamental doubt on what you have presented, because this kind of curve presenting capacity based on what is happening means that the airport is at its maximum level, something that is not always true, depending on the fleet mixture and things like that. We used to do this kind of things based on runway occupancy time measures, long time ago with a clock.
Yeah.
Right now, not with a clock, but using data for surface movement or from ADS-B or things like that. But when looking for the real capacity of the airport, this is not really capacity. This is flow of the airport. This is the aircraft flow, not really capacity.
That's absolutely right. Capacity can basically not be measured because you have to observe it.
I have to say that we have been doing this for long from a practical viewpoint. It is possible that academically could not be measured because depends on the fleet mixture and depends on a number of operational things, not only on the fleet mixture, but could be measured. I could guarantee you, because we have been...
You have to operate the airport at capacity in order to be able to measure it. That's what I meant.
Yeah,
exactly.
I understood,
exactly.
but there are other ways. I have a doubt that is not for you, it's for the rest of the people also around the table, is that apart from using measuring data, that is something wonderful, there are also ways like simulating things. And in this arena, there are lots of fast time simulators or things like that that could help you in doing the things. And you could calibrate those things with real data and then go to what is done and check with Monte Carlo simulations, changing the fleet mix and things like that. The impression I have with some of the things you are telling right now is that for sure, making reds at the airport increase capacity. We do that exactly for increasing capacity, reducing runway occupancy times. That's something pretty obvious. Except, and you have shown in one of your graphs, if the operation of the airport changes because of the COVID or because of the evolution of time and so on, and then the comparison is a bit useless because it depends on the fleet mix in every specific moment, depends on how the aircraft operators operate the things, depends on how clear are the instructions to the pilots to try to use one specific exit taxiway and things like that. So my question mainly was in the matter of distinguishing between flow and capacity, that are different things. And if you say that it's impossible to measure capacity, I don't know how to question you, but why not try to measure, to estimate, if you want, capacity?
Well, but I mean, it's not possible if you just use observational data. And that was our goal, because it doesn't really make sense to just rely on fast time simulation at the OSN conference.
Yeah, thank you for the comments. I think in the same direction. So I was head of department in the DLR. One of the things was I have going for the capacity things. So I have to, I was in, for the Düsseldorf airport capacity group. So we have to give the capacity for their extensions. And we were at Gatwick as well. And Gatwick is a funny case because they have a single runway system which operates at capacity, so they are really struggling with the problems. Yeah, and I was wondering a little bit because I know from the literature and even from the regulations that you should achieve at least a runway occupancy time of 50 seconds to be close to your capacity value, right? So, and I want to give the hint as well. There's already a tool provided by the FAA where all the aircraft are in there, and so you can find a good way for the capacity for the position of the rapid exit taxiway. But I think it could be. And this is, I would like to continue on this. Is a very nice idea to see the data and to estimate some capacity. We already talked about, right? So to make an assumption if the aircraft will be able to meet the rapid exit taxiway or the brake to vacate options. And then if you see this, then this could be a good measure for the airport. Like you will not make it, right? Something like this measure. And this really comes out of data.
But this brings us to the last point on this slide. We can only do that if ground coverage was better. Because there is also a little shortcut mentioned in the literature where you can identify whether an airport is subject to heavy loads or not, is always when there are queues formed in front of runways, which we cannot detect at the moment.
Okay, any other questions, opinions? Okay.
Hi, I'm definitely not as much of an expert as all the other questions. I was just wondering, have you looked at the number of holdings before, like pre and post red? Could you find a difference? Yeah.
No, we haven't. No, we haven't. But that could be an indicator as well. Yeah. Yeah.
But be careful. If you go to the holding, it's something like contingency, right? Normally you go for path stretching. So, okay, yes, but this could be an indicator. You have this kind. Okay, now we go to my lecture of airspace capacity. Yeah, but it's some indicators, and it would be very nice to, even to find some triggers, right? Mm-hmm. The triggers could not only be on the runway. We heard there could be some triggers in the air, and this is already in the. We could use it from OpenSky network. Okay, then.